Lesson 20-1. In order to study the relationship between the amount of sleep a student gets and his or her school performance, a researcher collected data from 120 students. The two-way frequency table shows the number of students who passed and failed an exam and the number of students who got more or less than 6 hours of sleep the night before. Use the table to answer questions 1 through 3. So number 1, to the nearest percent, what is the probability that a student who failed the exam got less than 3 hours of sleep? Less than 6 hours of sleep. To the nearest, what is the probability? Okay, so the probability that a student failed, given they had less, we'll say this is less and that's more, and then passed and failed. All right. So what do we got here? Also, probably who failed the exam got less than, so that's going to be the probability of less given that they failed. Okay, so this, what is the probability that this who failed the exam got less than, all right. So what do we got? Less than 6 hours of sleep is 10. And the number that failed is 18. So that's going to be what, 5 over 9. Let's go to our calculator. 0.5, we'll say 0.56. Is 0.56 or approximately 0.56. To the nearest percent, what is the probability that a student got less than 6 hours of sleep, failed the exam? All right, so now we're going to have the probability, that they failed given less than 6 hours of sleep. All right, so let's see. We're going to have 10 over 22. Notice the difference. Number 1 was this column here, and then number 2 was that row there. Notice the difference in the subtlety of the English language. That's 5 over 11. 5 divide 11. Control enter. 0.45 is 0.45 or 45%. Number 3. To the nearest percent, what is the probability that a student who got less than 6 hours of sleep, what is the probability that student got less than 6 hours of sleep and failed the exam? So now we're talking about the probability less than 6 hours of sleep and failed the exam. So that's the intersection of those two. All right, and then if we go back to our table, let me clear some of this up. Less than 6 hours and failed, that's going to be 10 and out of 120 students. 10 over 120, that's 1 over 12. 0.083. 0.083. So I'm going to just say 0.08. That doesn't round up. All right. Number 4, you have a standard deck of playing cards from which you randomly select a card. Event D is getting a diamond. F is getting a face card, a jack, a queen, or a king. Show that the that the probability of a diamond giving us a face card equals the number of the diamond intersection face cards divided by the number of face cards. And probability that a diamond given a face card equals the probability. Okay, so what's the number? The number of diamonds intersection face cards. Well, we got Jack, Queen, or King. That's going to be 3 over the number of face cards is 12. Okay. And what is that? 3 divided, that's 1/4, that's 0.25. All right, now what's the probability of a diamond given diamond intersection face card? What do we got here? So there's 3 over 52. Let's see what that works out to. 3 divide 52. That's 0.0577. 0.57, we'll just say 0.06. 0.06, okay. 0.06, and then probability of face card. There's 1, 2, 3 times 4. That's going to be 12. 12 divided by 52, and that's 0.23, 0.23. 0.12 over 52 is 0.23. Okay, so now let's try 0.06. 0.06 divide 0.23, and we get 0.26, which equals 0.06, we're talking about this one here, divided by 0.23, and that equals 0.26. The difference there is in rounding, because we went rounded up here. I think that was 577. Well, let's try that. 0.0577 divided by 0.23, and see their year. Okay, all right. So that's just rounded there. Not a problem. Number 5. The table shows data in the previous table as relative frequencies. Rounded, all right. So we're taking it to the next step. To the nearest percent, what is the probability that a student who passed the exam got more than 6 hours sleep? So now we're going to have the probability that more than 6 hours sleep given they passed the exam. All right, that's going to be the same as the probability of more than 6 hours sleep intersection passed the exam divided by the probability of passing the exam. Okay, so what do we got here? More and passed, that's going to be right here. That's going to be 0.75 over the probability that they passed the exam. That's going to be right there, 0.85. So 0.75 divide 0.85, and that's 0.88. 0.88. Let's go back here. Number six. To the nearest percent, what is the probability that the student who got more than 6 hours of sleep passed the exam? To the nearest percent, what is the probability the student who got more than 6 hours of sleep passed the exam? So this is going to be the probability that they passed given they got more than 6 hours sleep. Okay, so what do we got? What do we got here? They passed the exam given they got more than 6 hours sleep. So that's going to be 0.75 divided by 0.817. .75 divided by 0.817. I get 0.918. 0.918. So basically a 92% chance of passing if they get more sleep. All right, number 7. Which is greater? The probability that a student got, which is greater? The probability that a student who got less than 6 hours of sleep passed the exam, or the probability that a student who got more than 6 hours of sleep failed the exam? So the probability that a student who got less than 6 hours of sleep passed the exam, so that's P of A given L, and that's going to be, well, let's see, and then the other one is the probability that who got more than failed given they got more. All right, so what do we got? What do we got? Passed the exam given that they got, okay, 0.1. 0.1. It's going to be 0.1 divided by 0.1 divided by 0.183. 0.183. And then failed, given that they got more than 6 hours sleep, that's going to be this here, and that's going to be divided by. So we got 0.067 divided by 0.817. All right. So the first one, 0.1 divided by 0.183. That's 0.546 equals 0.546. And then we have 0.067 divided by 0.817. And that's 0.082. 0.082. So what do we, which is greater? The probability that a student who got less than 6 hours of sleep passed the exam, or the probability that who got more than 6 hours sleep failed the exam? All right. Well, this is definitely larger. Okay, definitely larger. Why? Probably because they studied. Huh. All right. You should still get your 8 hours sleep, though. Just time management. All right, so what do we got here? You randomly draw a card from a standard deck of cards. Let A be the event the card is an ace, B be the event the card is black, and C be the event that the card is a club. Find the specified probability as a fraction. All right. Let A be, so A That's going to be 4 over 52 because there's 4 aces. 4 over 52. And then B, the card is black. That's going to be 26 over 52. And C is a club, and that's going to be 13 over 52. All right. So the probability A, given me the probability of this ace, given that it is a black card, is going to be, ace. Well, that's going to be, well, that's going to be the probability that A intersection B over the probability of B. All right. Well, let's see. Black, probability is black. That's going to be 0.5. 0.5. A intersection B, there's two black, two black, A intersection B. Well, let's see. Why don't we do it like this? We'll do it like this. The number, that's going to be, there's 2 black, and then the number of B would be 26, and that gives me 1 over 13. Okay. 1 divide 13. That's 0.0, we'll say 0.08. 0.08. Number 9. Number 9. The probability that it is black, a black card, given that it is an ace. The probability that it is a black card, given that it is an ace. Well, again, that's going to be the probability, well, number of A intersection B divided by the number of A. Okay, so, and then what do we got? We have 2 black aces, and then we have 4 aces, so that's going to be 1/2 or 0.5. 10, probability that is an ace, given that it is a club. Well, let's see. That's going to be the number of aces intersection clubs divided by the number of clubs. And, well, there is 1 ace of clubs, and there are 13 clubs. So that's 0.08. The probability that it is a club, given that it is an ace. All right, so that's going to be the number of aces intersection clubs divided by the number of aces. And there is 1 ace of clubs, and there are 4 aces. So I'm getting 0.25. 12. The probability that it is black, given that it is a club. Well, let's see here. The number of black intersection club divided by the number of clubs, that's going to be 13 over 13, which is 1. So if you have a club, it is black. If not, somebody is a poor cheater. The probability that it's a club, given that it is black. Okay, so we got the number of black intersection clubs divided by the number of black cards. And there's going to be 13 of those, and there's going to be 26 because half the deck is black, and that's going to give us 1/2 or 0.5. "14. A botanist studied the effect of a new fertilizer by choosing 100 orchids and giving 70% of these plants the fertilizer. Of the plants that got the fertilizer, 40 produced flowers within a month. 40% produced flowers within a month. Of the plants that did not get the fertilizer, 10% produced flowers within a month." Okay, so we got to fill out this table here. And let's fill out the frequency table. So what did we have here? A botanist studied the effects of a new fertilizer by choosing 100 orchids. So we have 100 orchids total. 70% of these plants, and giving 70% of the plants the fertilizer. So we're going to have 0.7 times 100, and that's going to equal 70. All right, so if that's 70, then this must be 30, okay? 70 plus 30 is 100. All right, so we got that. Of the plants that got the fertilizer, 40 produced flowers within a month. Okay, flowered in 1 month, received it. So that is 40%, 0.4 times 70. What do we got? 0.4 times 70. That should be 28. So we got 28 here. All right. 70 minus 28 gives me 42. So I'm going to have 42 here. All right. So that covers that. Now, of the plants that did not get fertilizer, 10% produced flowers within a month. So we got 0.1 times 30, and that equals 3. So that means that must be 27. 28 and 3, 28, 29, 30, 31. There, that means this should be, let's see, 42 plus 27. That should be 69. There we go. And let's see, can we see? Yeah, we can see all of B. To the nearest percent, what is the probability that an orchid that produced flowers got fertilizer? So the probability that, what is the probability that an orchid produced flowers got fertilizer? All right. Well, that's going to be the number of fertilizer intersection flowers divided by the number of flowers. Fertilizer intersection flowers. I'm getting 28. That should be 28. And flowered would be 31. 28 divide 31. I get 0.9. 0.90. So 90% of those did their thing. And let's see here. What about C? What about C? To the nearest percent, what is the probability that an orchid that got fertilizer produced flowers? So probability flowers given fertilizer. Okay, let's see here. Let's go back. 48 or 28. It's going to be 28 over 70. 28 over 70. And 28 divided 70. And that's 0.4. 0.4. To the nearest percent, what is the probability that an orchid that got fertilizer produced flowers? And that's within 1 month. So 40% of them produced within 1 month that got fertilizer. All right. At a school fair, a box contains 24 yellow balls and 76 red balls. 1/4 of the balls are labeled win a prize. Match the description with the, I think there is a little, all right. At a school fair, a box contains 24 yellow balls and 76 red balls. 1/4 of the balls are win a prize. Match each description of a probability with its value as a percent. Okay, so we got red, we got yellow, win, not, and we're going to put total here. All right, we'll put total there. Well, let's see here. What do we know? We know 25% of the balls win and 75 don't, and there's a total of 100. We also know that there are 76 red balls. That means, and there are 24 yellow balls. So that's how we got 100. So we got 0.25 times 76. 0.25 times 76. That gives me 19. So we got 19 win, and then we got, let's see, 0.25 times, and that was 24. That's 12. So we got 12. Did I do that right? Oh, I did not. 0.25 times 24. That's 6. That looks better. 6. So 19 and 6 is 25. And then 76 minus 19, well, that would be 56, 55, 57. 57. And then here we're going to have 18. So that should work out. That works out. All right, good. That'll make doing this a little bit easier. So the probability that a randomly selected ball labeled winner prize is yellow. Well, that's going to be that would be what, 6 divided by 25. 6 divided by 25. That's 0.24. So 0.24, here's A. And then B, the probability that a randomly selected ball win a prize is red. Well, that's going to be 19 divided by 25. 19 divided by 25. And that's 0.76. And then let's see, the probability that a randomly selected ball is labeled win a prize and is red. Okay, so that's going to be what? well, it's going to be 19 divided by 100, which is 19%. So let's see. The probability that a randomly selected yellow ball is labeled win a prize. Okay. Well, the last one left is 25%. So that's D. And that sounds about right. 6 divided by 24. We good. 16. A teacher gave her student 2 tests. If 45% of the students pass both tests and 60% pass the first test, what is the probability that a student who passed the first test also passed the second test? So the probability they passed test 2, given that they passed test 1, let's see, 45% passed both, so we got 0.45. And passed both tests, and 60% passed the first, so that's going to be 0.6. So we have 0.45 divide 0.6, and that's 0.75 equals 0.75. What about number 17 here? You randomly selected 2 marbles, one at a time, from a pouch containing blue and green marbles. The probability of selecting a blue marble on the first draw and a green marble on the second draw is 25%. And the probability of selecting a blue marble on the first draw is 56%. To the nearest percent, what is the probability of selecting a green marble on the second draw, given that the first marble was blue? So probability of green given blue. All right. Okay, what do we got? Let's see here. Let's see, first on the first, and a green marble on the second is 25%. So we're going to put 0.25. And the probability of selecting a blue marble on the first draw is 56%. So I got 0.56. Okay. 0.25 divide 0.56. And that's 0.446, or we'll just say approximately 0.45. Number 18. Oh yeah, this is when it gets fun. You roll 2 number cubes, one red and one blue. The table shows the probabilities for events based on whether or not a 1 is rolled on each number cube. Use the table to find the specified conditional probability expressed as a fraction. Then show the conditional probability is correct by listing the possible outcomes as ordered pairs of the form, number on red, number on blue, and identifying the successful outcomes. Okay, so what do we got here? So I'm going to have probability of red, well, and then blue. That's the format it wants us to use. Okay, so not rolling a 1 on the blue cube, given rolling a 1 on the red cube. All right, so let's see. Probability of not blue given, well, it's a 1 red. Okay, so probability of not a 1 on the blue, so that could be 2, 3, 4, 5, and 6. So that's going to be 5 over 36. And then 1 on the red, and the only way that's just 1 over 6. Okay. And then if you do the arithmetic on that, invert and multiply, you're going to equal 5 over 6. Now, I got that here, and I got that there. Oh, sorry, I got that there. Not rolling a 1 on, let's see, not rolling a 1 on the blue cube. It's this one here, and rolling a 1 on the red cube. That's where I got those from. Now let's think about it. You got 1, 1, which that's not what, that we did not want that. Okay, that's what we didn't want. Then you got 1, 2, you got 1, 3, you got 1, 4, you got 1, 5, and let's see here, and 1, 6. These are the ones that you want. 3, 4, 5, 5 out of a total of 1, 2, 3, 4, 5, 6 out of 6, which is the same answer we got both ways. Okay, and this one here is just using logic to figure it out. And that one there is just using the table. All right. So I'd like for y'all to try 19 and 20 on your own and put those on the form. Thank you and have a good day.